Lesson 2, Polynomials, Complex Roots. Example 2. Show that x equals I is a zero of px equals x to the fourth minus x cubed minus x squared minus x minus 2, and hence or otherwise determine the other zeros. Now we'll substitute in x equals I into this, and we get p I equals I to the fourth minus I cubed minus I squared minus I minus 2. Now I to the fourth is going to be just 1. This one here is I cubed is minus I, so that'll be plus I. This is I squared is minus 1, so it's going to be plus 1 minus I minus 2, and of course that all gives you 0. Now because the coefficients of all these terms are real numbers, then the other solution is the conjugate of this, which is minus I. It only happens when these are all real numbers. If they're a complex number in front, this will not happen. Okay, so now we know that these are two zeros. So the two factors are x plus I and x minus I, and when you expand it out you get x squared plus 1 is a factor of this. Now because this is of degree 4, then we can say that px will be equal to x squared plus 1 times another polynomial of degree 2, and it will be a monic polynomial because when you multiply these two together you've got to get a 1 in front here, plus a bx. Now here the last number will be a negative 2 because you can see that this is a minus 2 here, so 1 times minus 2 must give you the negative 2. So all remains is to find out what that b is. Now you can multiply the whole thing out or do it partially, but I'll do the whole thing so you can see what's happening. So it's x to the fourth plus bx cubed minus 2x squared plus x squared plus bx minus 2, and grouping these together we get minus x squared plus bx minus 2. Now the original equation is, let's write this underneath this one, is x to the fourth minus x cubed minus x squared minus x minus 2. And I think you can see that the b has to be equal to negative 1. Therefore b equals negative 1, because these are identically equal to each other. Right, so we can say that px must be equal to x squared plus 1 times x squared minus x minus 2. And of course that becomes, factorizing this x, it'll be minus 2x plus 1. So the zeros are I, minus I, 2 and minus 1. Now the other way of doing it, otherwise method, right, would be to divide x squared plus 1 into this. Or the other way you could do it is you could try various solutions. Because we had a situation where we had 2 and minus 1, we could have simply tried 2, and that would have worked, minus 1, and we would have got it. But it's only because this was, we had integral roots, otherwise it would have been too difficult. And that's the solutions.